Now, after you paste an empty shell script into each one of these directories, go ahead and go into your video directory and look for the first movie. For mine, it's Family Guy. There we go. Alright, in your terminal, type in player. Now, I couldn't do this. I tried to do this on Windows once to cut my transcoding time in half. I only use the X264 codec. DivX codec is great, and it's fast, and actually you can transcode with DivX about 1.5 times faster than you can with X264. And DivX is widely supported, but though X264 takes a lot longer to transcode, and it's not as widely supported, it is a better codec. I wouldn't go as far as saying it is much better, but it is better, and in the future it will be widely supported. So go ahead and start off on the right foot by using the X264 codec. Now, all of my in-player profile, every profile under my in-player profile is set up to use X264. Now, you typed in player, hit space, and then just drag the VOB over so you don't have to type it out, and then just hit enter. Now, I don't know if the microphone is going to pick up any of the sound from the video or not. Also, this video is going to run really slow because as I'm recording, I'm also playing shit on in-player, which is very CPU intensive to do both at the same time. I've got a very fast computer, but it might not be fast enough to keep up with both. Now, you're probably not going to be able to see fine details because of the video being retranscoded by YouTube when I put this up. I'm going to start putting download links on my website so that when you're on my website watching the videos and reading along with the articles, you can actually download my original tutorial video, which has a much higher quality. Anyway, if you can see in this video, it is actually, you see combing effect when there's movement. That is indicative of a method in film that is called interlaced. It's when this whole thing is composed of fields. There's one, and then two, and then one, then two, and it displays each field in back and forth. It displays top field all the way down, which is even numbers of rows, and then it displays bottom fields in the next frame, which is even numbers of rows. And together they make the movement that you see. This is typical of movies, material, film, video, whatever you want to call it. It's all synonymous here. This is typical of video that you see that was made specifically for television broadcast. That is something that was either broadcast on television and turned into a movie, or just a shitty movie. A lot of old movies are interlaced. Sometimes when you're watching one that is telesigned, which is a mix between, it's like a hybrid between interlaced and progressive, not to get too specific here or too detailed about how they do it. When you're watching telesign, every once in a while you'll see a combing effect when there's movement, but it won't be constant. That's how you know it's telesigned. What you can do to make sure is just hit up to go back to the previous command and go to, now this is probably going to screw up my recording because benchmarking is very, very intensive. It plays the file as fast as it possibly can. We're going to add a dash benchmark flag to the end of it, then dash no sound, all one word, then dash VO for video out, and then space null to say don't even show us the video. And what that's going to do is it's going to run through this file as fast as it can and spit out lines about this file. And I can't spell, so there we go. Now if you see at the bottom, there's numbers going by really fast. It hasn't said anything about switching frame rate. So far it's still at the same original frame rate, which is displayed here on this line at 29.97 frames per second, which is the interlaced frame rate. Telesigned is 29.97, but it looks progressive. And you'll also see telesign. I'll go ahead and cancel it since we know it's interlaced all the way through. Well, you'll see telesign when it plays. Well, I'll show you in one of the next video. But when telesign plays, it skips back and forth. You'll see it spitting out messages here. Frame rate switched between to 29 frames per second. And then you'll see it spit out another message. Progressive content detected. Frame rate switched to 24 frames per second. That's telesigned, and if it's telesigned, or even if it's entirely progressive all the way through, which means there's no interlaced hybrid, it's completely whole picture frames all the way through, you still run the telesigned filters anyway just to be safe. It never hurts. Alright, so now we know that this is an interlaced video all the way through. So we're going to go and hook up a filter chain using the VF flag for video filters, then YADIF, which is yet another de-interlace filter. Type so you got -VF space YADIF, which de-interlaces it. Now what I'm actually going to have to do is change my desktop theme so that you can see the borders of the movie. Just pick a random one. I use the Audacity theme. Alright, now we're going to tell it to de-interlace the video as it plays and hit up a couple of times. As you can see, there's a border right here on the right, or you may not be able to see it from this video, but there's a black border right here on the right of dead space. You want to crop that out. So we're going to go YADIF and then comma, because this is all one chain. It's filtered by, or separated by commas for each type of filter. Then we're going to go crop equals. Now here's the thing about video coming from a DVD. It's almost always, I've never seen one that's not 720 pixels wide by 480 pixels tall. This is anamorphic video because when it displays, it never displays 720 by 480. It always displays 854 by 368 or 854 by 480 or 480 by 576 by 480. Anamorphic video, because television and DVD players can't play anything that's wider than 720 pixels. Believe it or not, the things that you watch on your DVD player are not as big as they look. They're just stretched out. The aspect ratio is corrected when it's played, but it's actually stored at 720 pixels wide by 480 pixels tall. Even if there's a widescreen, it's stored all the same. It's anamorphic. So we're going to crop it to 720, and since it's 2 pixels we got to shave off the right, we're actually going to make that 720 into 718. And then 480, we're not going to have to mess with that because it is the picture touches top and bottom of the borders. And then we got to set our offset for the rectangle. So our offset's going to be 0 for our horizontal offset, which means we're going to start at 0 pixels from the left, which means we're going to start exactly all the way on the left. We're not going to take it. We're not going to cut any off the left. And then since it's 718 wide, that means 2 pixels off the right are getting taken off. And then colon. And then 480, our offset's 0 because we're not cropping anything off the top, and it's going all the way from top to bottom. When you crop, it's crop equals, and then the width separated by a colon, and then the height, and then another colon to separate the offset, which is in this case 0, and then colon that's for the horizontal offset, and then colon, and then another 0 for the vertical offset. So now, if you look, there's no border on the right. It touches all sides of the frame, and you got to do this with in player's best to do this with, because VLC will still play a it'll put a border around it by itself. I don't know why, but in player's the most accurate depiction. All right, so now that we've cropped the black space out of it, and in one of my previous videos I'll discuss why you must crop black space, black borders out of video. Alright, now that you've cropped it out, you got to put it back at 720 by 480. So we're going to go scale equals 720 colon 480, and it'll scale it back up to 720 by 480. So it's back at anamorphic, and it puts it on even increments of 16 pixels. And in case I forget to mention in one of my earlier videos that I will actually be making later, everything has to be even increments of 16 pixels. That's because of the way the codec works, the way it transcodes everything, and then the way everything's decoded when it's played, that you will be it rounds everything up to 16 pixels even if the picture's not rounded to 16 pixels. It has to do it. So it's best to round everything up to 16 pixels anyway to get the best image quality, and to get and so you're not just wasting CPU overhead. Okay, so now that we've scaled it, put a comma, and the last filter we're going to use is the D size filter, which is display size. I don't know why it's called display size when it's actually your aspect ratio. So we're going to go D size equals 1.33, because this is a 1.33 to 1 picture ratio, which is full screen. it kind of looks almost like a square. 1.33 to 1 is also referred to as 4:3 as a ratio. And as you see